Hello everyone, thank you for watching my video today on the sum of arithmetic series or sigma notation of arithmetic series. To start here, there's a 3-problem opener that I would like you to pause this video and try on your own. When you are finished, you can unpause the video and check your answers with me. Here are the answers to the opening 3 problems. Hopefully you got those right. Now let's move on to the sum of arithmetic sequences. All right, so we talked briefly about this yesterday, but let's go into more detail today about arithmetic series. First of all, a series is just the sum of a sequence. So if this is a sequence, this is the series of that sequence. We talked about the sigma notation that we use. This is the Greek letter sigma that we will use when we write this out. It looks like an S. It's the S in the Greek alphabet. Well, I guess it looks like an E in the American alphabet. But we think of it as an S for sum. Okay, the summations would basically be just adding up all the terms from whatever this number is to whatever this number is of this explicit formula. This number here is called the index. N is called the upper limit summation. And 1 is called the lower limit of summation. So to summarize, let's write this in sigma notation here. So this is well, we can do this 2 different ways here, but we're going to write this in arithmetic form here. So a sub n equals a sub 1 plus n minus 1 times d. So a sub n equals 1 plus n minus 1 times 1. A sub n equals 1 plus n minus 1, or just n. Okay, now could we have done that without doing all that work? Probably. You could have recognized that pattern, but I'm just trying to show you what we're doing today. That goes here. Okay, and then we're going to go from n equals 1 to 5. That's what we're going to be doing on our problems today, looking at arithmetic series. So the first one here says use sigma notation to write a summation for this sequence. Okay, I can tell it's arithmetic because we're adding 4 each time, right? So my nth term is going to be 7 plus n minus 1 times 4, which is 7 plus 4n minus 4, or 4n plus 3. So sigma of 4n plus 3. I know n equals 1 will be our starting number. We don't really know our ending number here. So we got to do a little bit of work for that. What we're going to do is we're going to set 4n plus 3 equal to our last term and solve. Let's see here, that would be, I just did this wrong. It's wrong math, sorry. I subtracted 3, should be 204. That would be 51. So our top number here is 51. And that would be our sigma notation for that sequence, for that summation. At this point, pause this video, try the one below it here. When you've finished, you can unpause the video and I'll go through the work. All right, first the nth term, so it'll be 500 plus n minus 1 times negative 10, which is 500 minus 10n plus 10, which is negative 10n plus 510. So my sigma notation is going to be negative 10n plus 510, starting at 1. Again, we don't know that bottom, that last number, the last nth term here, so we're going to set 10 equal to this. And solve. If you subtract 510 from both sides, we get negative 500. And if we divide, we get 500 over 10, which is 50. Okay, consider the arithmetic series 20, 18, 16, 14. Write the explicit formula for the nth term. This is not anything new for us. We should be able to do this pretty quickly at this point. So a sub n equals 20 plus n minus 1 times negative 2 is our common difference. So 20 minus 2n plus 2, negative 2n plus 22 is our nth term. Write the summation notation for the sum of the first 25 terms. That should be really easy now. We're just going to put our nth term right here, and we're going to go from 1 to 25 for first 25 terms. All right, last one here. Syracuse University is building another small theater for practice performances on campus. The director needs to place an order for the number of seats tomorrow. He has hired you, a math major and actor, to determine the number of seats he must order. He has given you the following information. The front row has 40 chairs. Each additional row has 6 more seats than the row before. The theater has 50 rows in total. So, if we wrote out our nth term, this being whatever row we're looking at, the first term is 40 plus n minus 1, and the common difference is 6. So if we simplify that, we would get 40 plus 6n minus 6, which is 6n plus 34. So that's my nth term. Now for my arithmetic nth term there, I'm going to write a sigma, a summation notation, using that arithmetic nth term. And now I'm going to go from the first row to the 50th row. So that is my summation, or my sigma notation. And now it says we can use our calculator to answer this. So we learned this in yesterday's video. So we're going to go to second list in our calculator, and then math number 5 is the sum. And then second list operations number 5 is sequence. And we type in our sequence, our variable, our starting point, and our ending point. And we should get that there are 9,350 seats needed for this little theater. All right, that is going to do it for today's notes on arithmetic series. Tomorrow we will look at the sum of arithmetic series and how to find that using a formula. Thanks as always. See you next time.